So here we go today. So today we're going to do 5.3. We're going to add in the sum and difference identities for sine, cosine, and tangent. Tomorrow will be half angles and double angles. And then Friday we're going to start the law of sines, and you'll also get a take-home formative on Friday. Okay? So let's do these warm-ups together. Okay? So if I'm looking at the first one, what does that truly mean? Does not mean that x equals 5, no. Okay, so what, go one step before that. What does it truly mean? X plus 5 times x plus 5. Yeah. And so then that would be x squared plus 10x plus 25. Right? Because you double distribute, and then so you'd have to multiply these two together and these two together, and then you'd have to multiply these two and these two. Okay? So the x times x gets me x squared. 5 times x gets me 5x. 5 times x gets me 5x. Add it together and you get 10x. 5 times 5 is 25. Okay? Many people here on this one put down x squared plus 25. Now, let's work that mistake. What are people doing if they make x plus 5 quantity squared into x squared plus 5, or 2 plus 25? Nope. In this one, they're just squaring the x and they're just squaring the 5. And they're forgetting about multiplying by the inside ones, the green ones up there, up on top. Okay? So that's the mistake there that many people make. Don't be that one. We'll see that in a minute. Okay? Square root of 9 plus 16 is really the square root of 25, which is 5. Okay? What I've seen people do here, I'm not saying current people, but it is not the square root of 9 plus the square root of 16. It is not 7. Okay? The square root of 9 would be 3, the square root of 16 would be 4, 3 plus 4 is 7. So it's different. Okay? Those are two of the all-time Hall of Fame algebraic blunders. Okay? U plus or minus v quantity squared is not u squared plus or minus v squared. Square root is not, you can't just break up. If you're adding inside of a square root, you can't just break it up. Same thing in function. F of u plus v is not f of u plus f of v. Okay? That is different. Those can't happen. Today, what we're going to be talking about is we are going to be talking about the sine of u plus v. Now, this, algebraically, it flows that this is not going to be the sine of u plus the sine of v. Okay? It will not be that. It will be something different. And that something different, same thing with cosine, same thing with tangent. And that something different would be here in, I'm just going to jump right into it. I'm not a fan of these highlights. Okay? So these together make, I think these two together make number 18 on your sheet, but it's written a little different way, so I want to explain the difference. The way that it's written on your sheet is it says the cosine of u plus or minus v is equal to the cosine of u, the cosine of v, minus plus sine of u, sine of v on your sheet, if I'm not mistaken. Correct? On number 18? Okay. So if it's a plus here, it's a minus when you go to use the formula. Okay? And vice versa. If it's a minus, if you're subtracting the two angles, then it's an addition of the two terms inside of what you're using. Okay? These two are number 19, and those would be the sine of u plus or minus v is equal to the sine of u cosine of v plus or minus cosine of u sine of v. Move the tangent up a little bit so I can get them all in one. Okay. And then tangent is number 20. Okay? Why do we need this? You may be asking yourself, why? Why? The reason is, we're not always going to be on the unit circle. This allows us to do something like, what is the cosine of 75 degrees? Okay? Now, there is more than one way of doing this, but you will get the same answer. So I'm going to do this particular problem in two different ways. So my first way is I need two angles that are on the unit circle that add to be 75 degrees. Two angles on the unit circle that add to 75. 45 and 30. Okay? So this could be the cosine of 45 degrees plus the cosine of 30 degrees. Okay? According to formula number 18, this would be the cosine of u plus v is going to equal the cosine of u cosine of v minus sine of u sine of v. So that would be the cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees and the sine of 30 degrees. Go back up here and color code this. what is, on the unit circle, what is, excuse me, what is the cosine at 45 degrees? Square root 2 over 2, no pi? Because you started out with pi. Well, I want 45 degrees. Yeah, but it sounded like you said pi first. Yeah, like you were saying pi times the square root of 2 over 2 is what I had heard. Yeah, but it is just the square root of 2 over 2. Yes. Cosine at 30 degrees. Sine 45 degrees. Sine 30 degrees. Square root 2 over 2 times square root 3 over 2. Nope. Square root of 6 over 4. Square root of 2 over 2 times 1/2. Yeah. Can I combine those two fractions? Into what? No. Okay. Now, let's do this one a different way. Give me another combination of two unit circle angles that gets me 75 degrees. Either one of those are on the unit circle. We don't have 15 on the unit circle. But we don't have 15. Because 90 minus 15 would be 75. 80's not on there, nor is 5. No.
225 minus
225 minus 150. Be another one.
50 and 75.
But 75 is not on there. Yep. Yep. 135 and 60. Subtract. Yep. Right. So 225 and 150. I heard first. Okay. So, what is this going to be? So, give it to me. Cosine at 225.
Negative square root
Cosine at 150. Sine at 225. Sine at 150. Still need it to be the same. Negative root 2 over 2 times negative root 3 over 2. Square root 6 over 4. Negative root 2 over 2 times 1/2. Did you say negative first? What would you want to simplify out of it? Because they're all even, right? So you want to divide by 2. But the problem is you can't divide into a radical. Okay? Can't combine the top 2 radicals to the square root of 12 because it's not multiplication, it's subtraction. Okay? And the square root of 6 minus the square root of 2 is not the square root of 6 minus 2, which is the square root of 4, which is 2. Okay? Yep. So that's as simplified as it goes. Okay? Now, Katie is sitting back there, and I can see it in her eyes. She's wondering, Lynn, why in the heck did you do this same problem twice? For real. Okay? Why did I do the same problem twice? Bingo. Okay? You don't have to, we could have done multiple different ones. Now, there also is a combination out there where you would have gotten first negative root 2 over 4 and second square root 6 over 4. And that's the same thing. Okay? Okay? So there are multiple different combinations out there, all of them equally. In this unit, we will not accept decimal answers. We will only be accepting exact answers. Okay? Which is that right there. Okay? Let's do 5 pi over 12. And I don't care how we go about doing 5 pi over 12. We can either do it as a sum or as a difference. It doesn't matter to me. We're going to end up with the same one. Now, okay? So let's keep it over 12. So in my brain here, what I am thinking is I'm thinking off to the side here, I've got 5 pi over 12. Give me 2 combinations that get me 5 pi over 12. Or give me a combination of 2 numbers, 2 fractions, that get me 5 pi over 12. Pi over 6 and pi over 2? Pi over 2 not with pi over 6. Okay? Pi over 6 and pi over 4. So in my brain, I'm thinking 2 pi over 12 and 3 pi over 12, which is pi over 6 plus pi over 4. Okay? Give me another one. Another one. It gets me 5 pi over 12. 2 pi over 3 would be 8. And then minus 3? Yep.
And 6.
Yeah. Oops, nope, that's a pi over 12, not pi over 6. Tap. Give me another one. All right. Using one of those combinations, find me the sign at 5 pi over 12. The sign at 5 pi over 12. Agree? Square root of 2 plus the square root of 6 all over 4. Yeah? No?
Yeah. Hey, I got square root 2 over 4 minus square root. Oh, because on the side though.
Sign is plus minus plus minus. Look, right here.
Oh, wait.
Plus minus plus minus.
You stay with the plus?
Yep. In sign.
So if it was like.
Cosine is opposite. Okay, go back to your formula. I'm not going to make you memorize these. That's why we give you the identity sheet. Yeah. But you got to use your identity sheet. Or you're going to memorize. Okay? Tangent here now. Okay? So, off to the side, I'm thinking 11 pi over 12. What are we thinking for 11 pi over 12? What are we thinking? For 11 pi over 12. Combination of 2. 7 plus 4. Problem is that 7 pi over 12 isn't on the unit circle. Problem is that 5 pi over 12 is not on the unit circle. What? But it's 5 pi over 12. 8 and 3 work. Right? So this is going to be the tangent of 2 pi over 3 plus pi over 4. Here we go. Okay? So the tangent formula says, which is number 20, I believe, on your sheet. Okay? So this is going to be the tangent of 2 pi over 3 plus the tangent of pi over 4, all divided by 1 minus the tangent of 2 pi over 3 times the tangent of pi over 4. Yes? Okay. What is the tangent at 2 pi over 3? Negative square root of 3. Okay. So off to the side, we're thinking tangent at 2 pi over 3 is going to be square root 3 over 2 divided by negative 1/2, which is going to be negative square root of 3. So this becomes negative square root of 3 plus, what is the tangent at pi over 4? 1. Yes? Make the top look pretty. 1 minus the square root of 3. Make the bottom look pretty. 1 plus the square root of 3. Now, there comes a time all of this right here in green is another way of doing it. Okay? They equal the same thing.
So they equal the same thing, but they're like different numbers.
It's a way scenic road, yeah. So you might go down that rabbit hole where you might be going through Merrill to get to Mosinee. Okay? Alright? Let's work it in reverse. Which one is cosine, cosine? Sine, sine.
That's close.
That's cosine, right? Okay. Is cosine same or opposite? It is opposite. Okay. So that means that this is then going to be cosine of 42 degrees, what 12 degrees? Minus 12 degrees. So it's the cosine of 30 degrees. Which one is Sine, cosine, cosine, sine. Sine. So this is the sine of 7y blank 3y. Fill in the blank. Like cosine of 3y, sine of 7y. Is that what you're saying?
It's like flipping it.
Yeah. Because order doesn't matter in multiplication. So it was cosine, sine, like that, you mean? Or what am I doing with the 7y and the 3y? Plus, adding, because it's the same. Cosine is the same. So that one's just the sine of 10y. Okay? Tangent's the easy one. Because what is it? Tangent's the only one that has tangent in it, right? What are you saying, D? Minus? Because it matches, tangent matches the numerator sign, or the numerator operation, I should say, and it's opposite the denominator operation. So that's just the tangent of B. Yes? Okay. What I'm going to have you do now is I am going to pass out for you a worksheet that deals with double and half angle identities, which come out of these that we just did, the sum and difference of them. This is going to be a self-paced. You've got the remaining part of class today to talk about this, and then we will also finish this tomorrow during